warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. Children, we are going to learn a new chapter today. This is a new concept. You won't have learned this before. It's called as trigonometry. Okay, so we are going to learn introduction to trigonometry. You have two chapters based on trigonometry in 10th standard. So this is the introduction, and then you have application. Okay, so now I'm just going to introduce to the things in the trigonometry. See, here we are going to deal only with right triangles actually. Okay, so later on in future, if you take mathematics, you'll be learning more about it and more different kinds of triangles also. But initially, now we are going to learn only with right triangles. Okay, so this trigonometry, whatever we are going to learn, is applicable to only right triangles, not for any other triangle. So one of the angle has to be 90 degree. So first look at this triangle. You can see that this angle B is 90 degree over here, right? So you have to understand the triangle first. See, the side opposite 90 degree, that is the longest side, is called as hypotenuse. We all know this, right? Longest side is called as hypotenuse. And now you have two other sides, that is AB and BC, which could be just called as arms of a right triangle or legs of right triangle. Okay, so this is the longest side. Okay, so now when it comes to trigonometry, we have 6 trigonometric ratios. Okay, so they are called as sine, cos, tan, cosecant, secant and cot. See, I'll give you the full form. I'll write the full form of these 6 trigonometric ratios, but here we usually, when we do problems and all, we don't use the full form. We just write this, like, you know, sine, cos, cos, ta and so on. Okay, so sine is actual spelling is sine. Wait a minute, let me write it down. Yeah, so I'll write it with this thing. It's actually sine. That is your sine, which is usually written as sin. You don't read it as sin theta. This symbol over here is theta. Okay, this is read as theta. Okay, this is usually to represent an angle. Okay, like how we say, no, x, let x be the side of this particular thing, or length, or a number. You know, in word problems we use x, right? So similarly, for angles, to represent an angle, we use theta. Okay, this is just this is just nothing but an angle. Okay, so instead of theta, they can use anything, any alphabet could be used. Okay, so this is sine. You read it as sine, not sin theta. You read it as sine theta. And then the second one is cosine. Okay, which is usually written as just cos, cos, and it's read it as cos theta. Okay, and then you have tangent. Okay, tangent is read as just tan theta. Okay, and then you have cosecant. Cosecant is read as just cosec. Okay, and then you have secant, which is read as just sec. Okay, and then you have cotangent, which is read as cot. Okay, so these are the 6 trigonometric ratios in trigonometry. So there is a formula for each of them. I want you people to memorize this well. Okay, so now here, when it comes to theta, let me say this is theta. Okay, this angle, whatever I have written over here, no, this is your theta. So first, if this is theta, you should understand what are these sides. Okay, for this particular theta, hypotenuse remains the same as hypotenuse itself, that doesn't change, but the opposite side will be the side which doesn't touch angle A at all, that is the theta at all, that is BC will be the opposite side. Okay, I'll write OBP. And your side over here, this on which the theta is sitting, you know, this side is called as the base, or it is usually called as adjacent. Alright, so now if I am talking about angle C, let me say I am using a different pen color for this. See, let's say I am talking about this angle C. Okay, for angle C, if I ask you what is the opposite side, you will not say this is the opposite side, because for angle C, the opposite is going to be AB. This is the opposite side, and the adjacent will be this one, BC. Okay, so depending upon what angle they are concerned about, our opposite and adjacent changes, but our hypotenuse remains the same. It doesn't change. Okay, so now you have to remember this function. Sine theta goes like this: opposite over hypotenuse. This is the formula for sine theta. So if I ask you what is sine theta, the opposite is BC divided by AC. This is the formula. Okay, so opposite over hypotenuse is what you have to remember. And so you can even remember it as sine SOH, that is sine is equals to opposite over hypotenuse. Okay, then you can say cos theta. Cos theta is adjacent over hypotenuse. So here for theta, adjacent is AB, so AB over AC. Okay, so you can say CAH, cos theta equals to adjacent over hypotenuse. Then you come to tan theta. The formula is opposite over adjacent, so you get TOA. So if you want, you can remember this SOHCAHTOA. That is what just to remember, we just name this SOHCAHTOA. Otherwise, if you don't want to remember this term, you can remember it separately, like sin theta is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, and then comes cosecant. Cosecant is nothing but, see, the sine, cos and tan are the basic. Okay, the other three trigonometric functions are reciprocal of these three. Okay, cosecant is reciprocal of sine, 1 over sine, so it just becomes reverse, it's turned upside down. So hypotenuse over opposite. Secant is the reciprocal of cos, so hypotenuse over adjacent, and cot is the reciprocal of tan, so it is adjacent over opposite. Okay, so if you remember the first three, you can easily do the next three also, but you should remember which is the reciprocal of which trigonometric function. Okay, so these are the 6 trigonometric ratios you need to remember by heart. Okay, now we will do problems based on this. Now if they tell you given tan A is 4 over 3, find the other trigonometric ratios. See, tan A is given as 4 over 3. You look at the tan A formula over here. So tan is opposite over adjacent, right? So first we will see for A, which is opposite, this is opposite, and this is going to be adjacent. So for A, isn't it? Because they're talking about A, not C or anything else. So it's opposite over adjacent, and they have given clearly that it's 4 over 3. So I write 4 for the opposite and 3 for the adjacent. Now I need to find AC. So that could be done using Pythagoras theorem, right? So AC square equals AB square plus BC square. This is Pythagorean theorem. We all know that. We have been learning this from past 3 years or 4 years, right? So you must be thorough with this by now. So AB is 3 square plus BC is 4 square, right? So that's giving you 9 plus 16, which is 25. So AC is 5. Okay, so you get AC as 5. Now we have to find all the other trigonometric ratios. So except only tan is given to us, we have to find the other 5, right? So sine is opposite over hypotenuse. So for A, you see, opposite is 4, hypotenuse is 5. So 4 over 5. Cos is adjacent over hypotenuse. So see, what is adjacent for the A? It's 3, and hypotenuse is 5. So 3 over 5. Tan is anyway given, 4 over 3, that's given. So then you come to cosecant. Cosecant is reciprocal of sine. So it's 5 or 4 over 5 becomes 5 over 4 here. And secant is reciprocal of cos. So it becomes 5 over 3. And cot is reciprocal of tan. So it becomes 3 over 4. That's it, over. Okay, it's very simple. If you remember those 6 trigonometric ratios by heart, it's really simple and very interesting too to solve. It's a very scoring chapter, so you have to learn this properly. Okay, and this is the basics. Okay, so you understand it properly and solve the problems. Okay, so now we'll do few problems from exercise 11.1. The first question is based on how we have done this example, so you can do it yourself. Now the second question says in figure 8.3, that is this figure. Okay, this figure, they are saying find tan P, and this is 8. Tan P minus cot R, right? This is figure 8.13, let us say. Okay, all right. So this is what we have to do is we have got this triangle PQR. They have just given you PQ and PR. So first we should find out what is QR. So again we use the Pythagorean theorem. PQ square plus QR square will be PR square, right? The longest side is always is equals to the whole thing. Okay, so 12 square plus QR square is equals to 13 square. 12 square is 144. Q plus QR square is equals to 169, and you get QR square is equals to 169 minus 144, which is 25. So QR is equals to simply 5. That's what you're getting. Now you have to find out what is tan P. Tan P is see, tan P is actually opposite over adjacent, right? So opposite is what for P? For P, opposite is 5 QR and adjacent is PQ. So 5 over 12 and cot R. So for cot R, cot is actually adjacent over opposite, right? So adjacent over opposite. So what is adjacent for R? QR is the adjacent, right? And PQ is the opposite. So 5 over 12. So they are asking you to subtract both of them. So tan P minus cot R is 5 by 12 minus 5 by 12, which is 0. Okay. Now let's look at fourth question. They have given 15 cot A is equals to 8. You have to find out sin A and secant A. So do you know there is a 15 over here? You can move that 15 to the other side. So you get cot A is equals to 8 by 15. So it is cot is actually adjacent by opposite. So you draw a triangle over here, ABC, and they're talking about A, right? So for A, which is adjacent, this is adjacent, right? So I write the 8 over there, and this is opposite, so I write the 15 over there. Now I have to find the AC, as you know, using the Pythagorean theorem. So I get AC as 17. Okay, so I write the 17 over here. Now sine and secant is what they're asking you to find. Sine is actually opposite over hypotenuse. This is the formula. So opposite for A is BC over hypotenuse is AC. So 15 over 17. And now secant is hypotenuse over adjacent. So hypotenuse is 17 and adjacent for A is 8. So 17 over 8. This is the answer. Okay. So now come to question number 6. So if angle A and angle B are acute angles such that cos A is equals to cos B, then show that angle A is equals to angle B. So since they have used the cos, I am just drawing the right triangle, and let me say ABC. See, since they are saying cos A equals to cos B, definitely A and B will not have 90 degree, okay, because 90 degree will never be equal to any other things, and this is a special different thing, okay. Only A and B has to be some acute angles. They are given clearly over here. It's not a right angle. So A and B I mark in such a way that C goes for 90 degree, okay. A and B are acute angles. Now they are saying cos A is equals to cos B. What is cos actually? So we know that cos formula is adjacent over hypotenuse, right? So for cos A, for A which is adjacent, for A adjacent is AC and AB is the hypotenuse, and for B, cos B will be adjacent for B is BC over AB, right? Hypotenuse is AB. Now cos A and cos B is equal, they are saying. So AC by AB should be equals to ABC by AB. Now you can see that the denominators are same, AB and AB. So obviously the numerators have to be same. So AC is equals to ABC. That's what we have got. Now you go to the figure and see if AC and BC are equal. Okay, if AC and BC are equal, this means it's an isosceles triangle, right? And you in isosceles triangle, if the sides are equal, the base angles will be equal. This angle and this angle will be equal. So hence, you know, angle A equals angle B. So hence proved. Okay. Okay, so now I want you people to memorize the trigonometric ratios thoroughly, and then from exercise 11.1, just solve problem 1 to 6. Okay, do all the problems from 1 to 6 in classwork. Okay, including whatever I have done today. Okay, all right then. So I want you people to also write these trigonometric ratios. So in this page, everything has to be written, all the notes also. Before exercise, whatever I have given, you have to write. You know, this example 1, you can skip it if you want, not required. Okay, this is not required, but apart from this, everything else has to be written. That is this, especially the trigonometric ratios. Write it clearly, make a draw a colored rectangular box, and then, you know, keep memorizing it. All right then. So see you next week with videos from trigonometry. We'll continue. Okay, we'll continue with this chapter. All right. Okay, fine. Allah Hafiz. Thank you.